of you have joined already here in my course, and yes, almost around 612 of you have enrolled for examination also. That's very good count for this year. Yes, what I find again is um, quite a lot of you have not attempted quite many module quizzes. I would suggest you go for the quizzes in time so that you don't be very much pressurized at the end. Okay. So this is a good note that I could make. That's very good count for this year. So I'll just find again. So yes, what we did in the first class, we introduced you to the course that basically was dealt with what is the prerequisite and all. Hope you all know it. I have designed this course in such a manner that it is well applicable for industry people as well. But for academics, you see there is a huge lot of syllabus which is here, and all of these are covering well this robotics aspects in a mechatronics way also. I have been repeatedly telling you, because you see you have actuators here, you see you have actuators here, you have sensors here also, that is coming as a next module. I think you have already done with first 2 3 modules. So that is mostly the building blocks of robotics. That is mostly the building blocks of robotics. In most of the test book, it is not very much covered in detail. Even the test books, or you should say different courses which are already there, it is not much covered. So what this gap is still there in the industry, in the academics, that people can learn robot well, but finally in terms when it comes to apply them to robot or to understand a particular industrial robot, it becomes very difficult, because they are made with a different kind of system, not like our amateur toy kind of. It is not using toy motors like DC motors, a small DC motor, or DC motor H-bridge driver. They are made with AC servo motors, right? So that was the reason. In order to have a chronology in building up of all those aspects, I have covered them all. And in the modern robot that you have seen, like a cobot and all, so you see it uses BLDC motor. BLDC motor. So that is the reason, again, I have included BLDC motor also in this course, so that you get to know at least 4 parameters that you are required to control. First is position. Without position, you cannot define a joint position. You cannot define the end effector position. So a position is to be required. Velocity, you have to move your robot with a particular speed. You have to have your joint also moving with a particular speed also. So that is the reason: joint position, joint velocity, and joint acceleration. Joint torque is also to be controlled. If you have to control the end effector forces, in those cases your joint torque is also to be controlled. And fourth parameter is the direction of the velocity. Okay, which direction you are moving, which direction you are applying torque. You can change the direction, position, velocity, and torque. So all the 4 kinds of control I have included in this course. That is what is making the actuator a complete module, and that too with all kinds of motors. That is BLDC motor, or a synchronous AC motor, or a DC motor also, because older robots are made up of DC motor also. So that is the reason being this whole thing is included here in this code. No one should take it as it is the part of a electrical engineering student. No, as such, robotics is more of a science than an engineering. So that is and your robot is not complete without these actuators or a knowledge of sensors. Okay, so that is the reason. So, and even a mechanical engineer is supposed to understand how a DC motor fundamentally works. I have not included the phasor diagram or a vector diagram or current calculation, flux leakages, and those electrical engineering aspects here to make the things very simple. So it is very much applied even to mechanical engineer or marine engineer or a mining engineer or civil engineer, for any engineer. You see, you have to understand a machine first. Even if it is a washing machine or a AC, why an AC is known as a dual inverter AC? Anybody know it? Can put here in the chat box. It is a dual inverter because it has, if you have gone through this module actuator, you see it is a BLDC motor which is there in your ACs. So what you have is a AC as an input, you convert it to DC and AC back so that you can control the fan speed, because fan speed is dependent on the frequency, not on the voltage. So what you do, you have a kind of a variable frequency generator, which is the drive of a BLDC motor system, or even in case of AC servo motors, so you have a variable frequency drives. So in case of AC motors, BLDC motors which are there in your AC, so what you have is a inverter. So first inverter is there in your indoor unit, which controls the indoor unit fan, and second one is there in the outdoor unit, which also controls the speed of the outdoor unit fan. Both of them are BLDC motor, and that is the reason why it is 5-star rated. So you got it. So even an AC has got dual inverter system, a AC inverter based system to drive its motor. So take it for a washing machine nowadays or a BLDC fan nowadays. So any equipment, electromechanical device uses this technology. So we have exposed you to these technologies, and finally you will be made to use this technology for your purpose, that is robots. So modern robots are made with BLDC motor and AC servo motors. DC were also there in earlier motors. Even for small mobile robots, we still use them. It is not obsolete though. So that is the reason I have used it. And for CNC machine and for printer, fax, Xerox machines and 3D printers, they all use stepper motors. So the whole of this module is designed in a way to make you more of a mechatronics engineer than a robotics engineer alone, so that you can understand robotics better. And finally, we also have a module where I have dealt with how to deal with such motor when you have a robot in hand, an industrial robot in hand, how such system look like. So that was the first module in actuator, first lecture in the actuator module that elaborated upon this. Okay, so this is how we went on for actuators. Similarly, we'll go for sensors also. Sensors will have all these discussions. When I am discussing only the position sensor, velocity sensor, acceleration, proximity, and force sensor, not a pressure sensor or a temperature sensor. Why? Because they are not used in for robots operation. But yes, for safety reasons, you may have temperature sensor also to see if the robot is running hot. Got it? So even temperature sensor could be significant here, but I haven't included it because for mechanical aspects, it is not very much required. So I have included all the sensors here. Later on, we'll go ahead with the forward kinematics that will come later in the course. Okay, hope you are doing well and understanding the things. These are very, very fundamental things. And I'll tell you, these are not there in so elaborated manner in any textbook or any course. So that is the reason this 12-week course is very, very important. There are many courses which are there online now, including NPTEL course or a Coursera course or many other open floating courses. So this is one of a unique course which covered well the mechatronics aspect of robotics. And then we will be approaching even the UG, PG syllabus which is there in universities. And for industry people, I'll say this is a boon kind of course that you had it here, that it will let you understand for which you have been struggling since long time. I have seen many engineers, they come to me with this query, sir, how we can maintain a particular kind of servo motor, how we can select a servo motor. My robot has gone bad, one axis is not working. So now they can at least talk to an engineer who is selling a servo motor. they at least can understand the technical specification of their motor. Got it? How it works. So where should they look for? Okay, so they can now understand very well. Later on in the course, we'll try to go in a similar depth, application depth also, forward kinematics, inverse kinematics, and there are many unique modules which are there in the course. I would suggest you go thoroughly with each and every module so that you appear well for your quizzes, every assignment which is there at the end of every week. Okay, please attend them, please appear for that and score good marks. And finally, at the end, we'll have a good quiz. Don't worry about that now. It is too early for that. It won't be very tough though. But yes, it will be very applied, and it will be from your video lectures directly, 100% from your video lectures. So need not to worry. Okay. So yes, thanks for the feedback. I could see on the YouTube post now. Your class is very much interesting. Please explain the application of industrial robots as manipulator. Yes, the first module itself explained it very well. You see, robots are used for pick and place task in the industry. You have plenty of jobs where you need to pick up an object, let's say from a moving conveyor, and place it on a bin, on a box, okay, which may be a carton, which may be a packaging thing. So you have to do pick and place. Not just that, your robot is used to do welding, to grinding, polishing, buffing, cutting, laser cutting, right? So you see, there are many applications, and there is a specific video in the module introduction first week. Application videos there. It is not just in the industry, it is there as an amusement video that also I have shown. I have shown it being used as a medical robot where it is implanting hair in one of the scalp. Okay, so yes, it is there. So yes, I would now, as I have already covered, I think 3 modules so far. 4th one has just floated. So yes, if you have any specific query related to the videos, you can definitely get in. You can post it in the Google group. I see very less query which is there in our groups. Okay, please bring it there so that our TAs and we can answer you very well. Yes, in the healthcare, somebody asked, it is there in the healthcare also. As you see, the laparoscopic surgery, how do you think nowadays it is done? How the laparoscopy dent is so steady? It is handled by manipulators, robotic manipulators, which basically does all these. Okay, so even eye drug delivery in the ocular surgery is done like that. So laparoscopy dents are no more holded by the robot, by the doctors. Okay, sometimes they are teleoperated by the doctors. Okay, so doctors are there in the loop, but yes, doctors see it live in their cameras and they do that kind of surgery. So it is there in the healthcare also. Okay, sir, did you cover the CS programming part? Yes, it is there, programming part. You can download a few which we'll be providing in different resources that comes later during the course in forward kinematics, inverse kinematics. You can download them all. Yes, there are few things which are there related to programming, and as such, robot programming is covered at the end in the last module. That is specifically the last module includes the robot programming. That will include the programming a robot as such, not using a standard programming language. But yes, doing forward kinematics, doing inverse kinematic, that one should be able to do it even with standard programming. So that is, yes, it is covered, but not as a CS perspective. It is with respect to a design engineer perspective who want to use the robot for their purpose. So as the course title, course objective is, it is not for the programming aspect. It is more, programming is very trivial. If you want to use any of the principles which are taught in this course, it is very simple. Okay, you can directly use those steps and you can do forward kinematics. You do inverse kinematics. So programming, I have left it on you, but sample codes we are providing. as a course download. You can directly ask me even in the Google group. I can attach it and personally send to the group so that anybody can use it. I would expect such question in the group also. So make that group very, very healthy and communicative to everyone else so that others can also benefit from your question. Okay. And one more question by Syed. I see, sir, any assignment 2, question 14, there is an ambiguity. Can you please clarify? You can please come back specifically in the group. Will definitely explain it. I don't remember what question was there, and I don't have any access to that here. So yes, please come here as a mailing reply. We'll definitely clarify it. Don't worry, Syed. Okay, hope you have done it well anyway. You can always, I think you can reattempt a quiz if it is ambiguous or something like that. At least assignment you can reattempt it. And there is just one exam that is going to happen. So you can always improve upon something. So yes. So any other question if you have, you can definitely come here. This is a live session. This is a good opportunity. You can have a vague question also, not just related to course, application thing also. I expect it here. Yes. Thanks, Sayed. Yes. I would wait for your reply with a more specific detail on ambiguity, which you are telling. And question number 14, definitely will come back. Okay, so this course is very much applied. You see, it is not just theoretical. You should not expect that you go through this course and directly appear for your UG exam. You should be able to do it. That is a subset of this. But a higher objective of this course, 12-week course, is how you apply this robotics knowledge for a particular robotics system. For if it is installed in your robot, if it is there in the industry, you should be able to judge on it. You do some kind of maintenance, maybe. You see, there are specific modules like installation and commissioning. That also is there as a one full week course. Okay, so in this we'll be explaining you how a robot is installed, how it is grouted, how do you do drilling operation, how do you select the foundation system, mastering a robot, how does a robot know its zero location before it measures its joint angle. Where is the zero which is lying? Okay. Say, do you want to have any correction somewhere? Correct formula of torque. That is going to come. We haven't covered it still. We haven't covered it. So whenever we'll cover it, we'll have another interactive session. If you are going in advance, looking at the videos, maybe earlier videos, it is good. But I would suggest let it come and we'll answer you. Because I am here for many other audience also who are attending my course. So this is A cross.
What he is actually asking is, what is the formula for torque? I mean, relation between torque, moment, and magnetic flux. So basically, the relation is tau equal to m cross b. Basically, m is the moment and b is the magnetic flux. But
Yes.
he's having some doubt in that. So actually, A
Yes.
option is correct, and we are giving that one only.
Good. So hope you have you got your answer, Sayed. It is my Himanshu Vasne. He's TA for this course. He is also here. So I'll get the feedback maybe little in there is a quite lot of latency which is here. That is quite normal for anything. Okay, so that is visible here also. You please take the snapshot, also send it in the group. If you are not getting it quite clear here, you can also send it to the group and we'll answer it there. So other than technical also, if you have any query which we can verbally explain it here, will be more nicer here. Yeah, Himanshu, can you please repeat the question?
Yeah, actually, sir, what he's asking is, what is the relation between torque in case of DC motor, PMDC? What is the relation between torque, magnetic, this moment, and magnetic flux density? Okay, where M is the magnetic moment and B is the magnetic flux density. So we have given option as tau equal to m cross b, and then tau equal to b cross m. Then third option is both, and fourth is none. So actually the correct relation is tau equal to m cross b. So that is why the option 1 is correct even in the assignment also.
Okay, I got it. I got it. Yes, it is quite correct. So, yes. Hope you have got it so far. Okay, so yes, so this is all that I could say for now, because you see, we have done just 3 modules and it should be quite clear here. Okay, later on we'll see very much in detail many other aspects also. Okay, that is yes, installation thing is there. That is what I was discussing. You see, you have now you will have knowledge about various ISO standards later on also. That is very helpful to understand industrial robots. Apart from what other books, many books have covered, so you should have some knowledge about different standards, technical specifications. See, now I think a lot of you are very much conversant with at least technical specifications of a robot. Okay, technical specifications of a robot, that will be very, very useful. Okay, if there is any other query by anyone else, thanks Syed for interaction. Hope you are doing well. Yes. We'll wait for another few minutes and then we'll log off. If there is any other query, we'll, yes. Sir, from the random robotic engineer guy found from LinkedIn, he have a skill like robot commissioning, robot programming, machine vision simulation. Can you brief this skill escape programming? I didn't get you right, but I think what you are asking is from a random robotic engineer. I expect you are not a robotic engineer or what? Robotic engineer found from LinkedIn. I have got a skill like robot commissioning. Yes, definitely. This course deals with robot commissioning, definitely. That is there in the course. If you see the curriculum, it includes installing and commissioning a robot. Yes, it is very much required. It is not only for somebody who is using a robot as an end tool, but yes, when you select a robot, you procure a robot. This course is also there for industry practitioners, for teachers who have procured robots for their labs. They do require these skill sets. Even for most of them are going to, even for students, they will be doing this job somewhere in their life later on if they hope to become a robotics engineer. So that is that forms the teachers, the industry personals, and students who intend to become robotics engineer. These knowledge will be something very unique for them. They become a unique engineer who knows about installation before they have actually done it. This is covered in the course. So that is the reason it is here. It is not for any guy who has just passionately come here and they are not going to install it. They just want to understand it. So you can definitely do this video. You can skip this video and move ahead. Others may be useful for you. So overall, this 12-week course is designed in such a way to be very inclusive to different audiences. University teachers, mostly industry practitioners, and to students who wish to go abroad and do practical implementation. Also those who want to make robot. Now India is making robot also, so that is the reason. It is not just for UG PG curriculum. Okay, so that is why it is here. Good. So yes, any other query if you have? Machine vision I have covered much, because that is not there in the course, because that is a separate, it's a huge field. Machine vision, if you think of, it is a separate field. You have to talk about cameras, camera photography, how it is done, pinhole camera model, stereo camera model, creating a 3D model and all. So it is a huge field altogether. So being so, I haven't covered that in our syllabus here. So you see, I have also shown you the circuit diagram of actually how a DC motor is operated using a standard industrial servo drives, or a servo motor is operated. The whole of the schematic using industrial IO, industrial PCs, and Ethernet, Ethercat communication, or complete industrial system, I have demonstrated it. So whole of that video you can see it after every week at the beginning of actuators. Same will happen even for sensors when we do it. So similar schematic will be shown. So somebody who is interested to implement it directly can take up those kind of things, and then they can rig up such circuit and directly work on it. You can come back if you are already doing it. You can always come back to us, and email will help you out. Maybe you can comment, put the comments in the YouTube specific lecture also. That can be answered later on, even after this course. Okay, so I am continuously following these videos, which is listed on IIT KGP's site. Okay, so yes, any other query? Thanks a lot for so many of you joining here and coming with some queries at least. So I hope it is going on very well. You are learning, and yeah, as the course progresses, you will find a huge amount of thing which is there. Installation commissioning is there. Okay, and safeties, configuring safety zones. Robot calibration is a huge thing that we are covering here. Tool center calibration and all. Somebody of you are already using it. We are covering the complete mathematics of it. We have done huge lot of research when we designed this course. Okay, so that is the reason it is there now. A whole lot of research is done. Finally we came up, yes, we should include this in our course, because it is there in your teach pendant. It is a robot is allowing you to teach your robots tool. Why that mathematics is not covered in any course? So that is the reason we have included that mathematics here. So same with rotary turntable or a linear mouse. We'll cover them all in module 7, 6 if you see there. Okay, so yes, that's all. So far, module 3 and 4 is done. So queries are addressed. So as it comes, I'll address those questions also. So yes. Okay, if there is no other query, we can end it here. It was a nice interaction though. We'll wait for second interaction session also. If you need more interaction after this course, we can arrange for that also. So far we have arranged for 3, but there can be more, I hope. IIT KGP will support me with that. Excellent. So that's all for today. I'll end it here.
Yes, sir. If you have no questions or queries, then you can close the session.
Okay. Thanks a lot. Thanks a lot. See you.
Sir, should I stay or leave?